Assalamu alaikum dear students. In this video, we'll be discussing simplex method. This is a part of linear programming problem. So simplex method, actually this is an algebraic procedure for solving system of equations where an objective function needs to be optimized. So question is, why do we need this method? Life is not simple. If you have more than three variables and you want you want to show graphically for more than three variables, so how can you? Suppose you have x, y, and z. Okay, this is three. What about four? Just I know you studied the Lorentz transformation, x, y, z, and time, but here in linear programming, you have more than three variables. You want to present graphically, so now it's not feasible. So that now this way to overcome this problem. So who can overcome this problem? This method, simplex method. So. So you need to transform, as we learned in previous lectures, linear transform problems, you had a set of constraints. So now we transform that set of constraints into a simplex method. So this lecture is based on how to transform a set of constraints, into this method, simplex method. So first is a transformation procedure for less than and equal to constraint. For this constraint, this type of constraint, for example, 3x1 plus 2x2 less than and equal to 4, just you need to add, here is a one variable, 3x1 plus 2x2 plus s1 is equal to 4. This variable, we call it slack variable. This is slack variable. So just we add one slack variable in left side. And right side should be positive. You remember, this is one of a condition for this method, simplex method. The second transformation procedure for greater than and equal to constraints. You have a constraint equation, x1 plus x2 greater than and equal to 10. So just you add two variables, then it will be transformed. One variable is E1, that is called is a surplus variable, and A1 is an artificial variable. So we add two variables, okay, for these conditions. For third transformation process, 4 equal to constraint. You see this, equal sign, greater than equal sign, less than equal sign, and the constraint. Just need to transform, into simplex method. So if you have equal constraints, so 3x1 plus x2 is equal to 10, 3x1 plus x2 plus a1. A1 is artificial variable. So one more thing is E1, A1 here. If you have more than constraints, so you write E1, E2, E3, E4. Similarly, A1, A2, A3, A4. This subscript shows number of constraints, and this variable belongs to which constraint equation. I mean, a second constraint equation belong to E1 is like a first constraint, and E2 is belong to second constraint, E3 belong to third constraint. Similarly, A1, A2. So like this is like first constraint equation. So like first you were talking about first constraint equation, we add e1. If you want to like add, suppose you see this sign greater than or equal to, you add e2. Okay, anyway, okay, I will show an example, and we'll solve one example. Okay, so now we have three technique, transformation technique: less than, for less than and equal to, for greater than equal to, for equal to. So now we have a question: transform the following constraint set into the standard form required by the simplest method. So first constraint equation is x1 plus x2 less than or equal to 100, and second constraint is 2x1 plus 3x2 greater than or equal to 40, and third constraint is x1 minus x2 is equal to 25. So now we need to transform. Here you see less than or equal to. For this type of constraint, so we add one. Add one variable, that is a slack variable. So x1 plus x2 plus s1 is equal to 100. So for second equation, so how we can transform 2x1 plus 3x2, you see, for greater than or equal to sign. So for greater than or equal to constraint, we just add two variables. One is a surplus variable, and second is a artificial. So now this a surplus and artificial variable belongs to second constraint equation. So we add e2, we use the 2, e minus e2 plus a2 is equal to 40 here. So for third constraint, for our third constraint, x1 minus x2, you see here sign equal sign. So we add one artificial variable. So a3 is equal to 25. So this is a transformation. Okay, so I hope you understand. So we continue. We will continue this lecture. So I will teach how to solve simplex method problems. So for now, thank you.